Okay. Hello. And good morning, or better good afternoon, and welcome to the what we call the afternoon part of today's program. And I welcome both viewers on our live stream, which you can watch continuously until tonight, where we hopefully get acquisition of signal on ESA.int. And of course, I welcome also the audience here on location at ESOC in Darmstadt in Germany. My name is Marco Trovatello. I work for the ESA Communication Department, taking care of digital media. And from this point on now until 21:15, we will have a series of dedicated presentations on both the ExoMars 2016 mission and the 2018 mission. And that will comprise detailed info on ExoMars science and technology, on the scientific goals of the mission, on the operational challenges, and of course the key milestones of these missions. My colleague Jocelyne Landau, she will provide regular live updates on the status of the mission in between these presentations, which you will see now until more or less like 1900 CET tonight. And we'll also have question and answer sessions. With regard to these question and answer sessions, you can also always follow the latest updates via our Twitter channel, the dedicated one at ESA_ExoMars. The hashtag is ExoMars. And in case you want to ask questions via Twitter, please also use the hashtag AskESA. The experts will partially answer here on stage. And the next speaker, which is coming up, Michael Kahn, working here at ESOC, he will also answer your questions in a dedicated Twitter Q&A session starting 12:45. So I really ask you to stay tuned and follow that. Going back to Michael and his presentation, the title of this session is Orbital Mechanics and the Journey to Mars. Michael is a mission analyst and engineer, a European of German nationality, and he works here at ESA as mission analyst, just said that, not just for ExoMars, of course, but for a multitude of other missions, and he is involved with ExoMars since 16 years. Remember, Twitter session with him, 12:45, so following that talk, and now over to you, Michael.
Thank you. We've seen this morning. Well, the sky was overcast, so we didn't see the rocket ascending. This is a computer animation. It looked like this. The first stage, the second stage, the third stage, everything went flawlessly. Now here we see the fairing separation, and the breeze is now exposed. The breeze is the stage that is just below the ExoMars payload. And the whole thing will take 10.7 hours, and the main engine will fire another 3 times. We're going to be coming up to the second burn soon, and there will be an empty fuel tank discarded between 2 of the maneuvers of the breeze. So it's really a lot going on there. It's a really complex strategy. And then finally, what we're going to see at 9:15 our time this afternoon is this separation. We're not going to see it actually, but this is what's going to happen. And then afterwards, after the communications have been established, the first thing that's done is the deployment of the solar array. Is always the most important thing to do, because without electricity is to a spacecraft like air or blood to a human being, we cannot live without that. The spacecraft needs electricity, and first thing is to get power into the batteries back again. So, but then comes the actual flight to Mars. Now that's easy, right? Everyone tells me, journalists and other people tell me how to do it. So you wait until Mars is closest to the Earth, and that's the point. Then you go, right? Like here, like so. And now the question is, why didn't we do it like this? Now this would be one explanation. Actually, the way we did it is like I'm showing here. So it's really a transfer that's more conventional, let's say it like this. So you can see the spacecraft So ExoMars will be, whoops. Okay, sorry. A little trouble here with this. Yeah, I know. It's good, so I can explain it again. So we have here the Earth, we have Mars, and we have the spacecraft as it goes out and encounters Mars. You see Mars catching up with the spacecraft, actually. So that's the way it's done. And in between, on the 28th of July, we're going to have a rather large trajectory correction maneuver, a deep space maneuver, 340 meters per second. That's also unusual. Most missions don't have that. And here it just happened to be optimal to do it this way. So this is the way it's going to happen. Then finally, this will be on the 16th of October, 3 days before arrival, separation of the EDM and of the Schiaparelli craft. And actually everything that comes afterwards is really much more interesting. What came up to now was very much straightforward, and the interesting things come after that, because that is where I'd say 90% of the mission analysis work was invested. But there's going to be another event here when that happens. So in 7 months and 5 days, same place, same faces, and but hopefully then a lot more different things to explain. And the Schiaparelli craft will be explained in great detail by my colleagues after the break. And then you will also hear about the science complement on the Schiaparelli craft and the science experiments on the TGO. All these people are here and are available to answer your questions. So much for the transfer. So this covers the rather straightforward next 7 months up to encountering Mars.
Michael, we have 2 live questions from Twitter before you head over for the Q&A session. Question number 1 is by Vincenzo Galdi, and he asks, what is the force that drives the module to Mars? Is the fuel sufficient for the long 7-month journey?
Okay, actually fuel is not needed to fly in space because the rocket gave it a hard enough shove, and now the spacecraft is in a, well, not yet, but it will be, after escape, will be in a heliocentric orbit, which will take it out to Mars anyway. The fuel is required to correct the orbit, and the fuel is especially required to insert into the orbit around Mars, to slow the spacecraft down so it will be captured around Mars. Otherwise, it would just do a swing by at Mars, and the orbit, the heliocentric orbit, would be changed, but that wouldn't be what we wanted to do.
Okay, so for Vincenzo, we hope that answers his question. The next question is by Kasper, and I can't spell the last name. What is the total distance ExoMars will be traveling?
If you just plot along the trajectory, it will be around 500 million kilometers up to encountering Mars.
That's a lot, 500 billion. Okay. Many thanks, Michael. And, well, yeah, we'll be back here with the next session, which will be on ExoMars Orbiter Science at 1300 CET. In the meantime, if you have questions, use ExoMars and ask ESA. Thanks for now. See you at 13.